Today we're going to talk about powers of monomials. Okay? Powers of monomials. Can somebody guess what do you mean by powers of monomials? Means, anybody want to guess? Yeah, what do you think, sir? Exponents, kind of. So, like something like this. This is what I mean. Like, you have an exponential form and then it's raised to another power. That's what we mean by powers of monomials. You see my monomial, x to the second? Now it's x to the second to the third. So let me ask you this. What's the base of the exponent 3 on this problem? One person knows? Raise your hand. 2, 3, 4, 5. How about Song? What do you think? X to the? Oh, that's the answer. But what's the base for this exponent 3? X to the second power is 5. So what does this mean? It means to multiply the base how many times? 3 times. So that means x to the second, and x to the second. This is why Song is correct. We get x to the 6 because you add all the exponents. You guys remember that? Right? So that's what happens. Now, this is using the rule that we learned last time, right? That was our first rule. But does anybody see any shortcut? If it's something exponential form to another power, there's a shortcut if you see something like this. If it's raised to another power, if it's power to a power. Chris, what do you think we do here? You multiply the exponents. Okay? Do you see how if I do 2 times 3, I get 6? Right? So if the exponents are right next to each other like this, you just have to multiply them. And you get the answer. So this is a shortcut. Question?
How do you know the difference when to add or multiply?
That's exactly the question I was going to ask. So this is when you multiply, right? This is our second rule. Look at our first rule. Anybody see the difference? What's the difference between the second rule and the first rule? Because you're right, Jason. People on the test or quiz, they add when they're supposed to multiply the exponent, and then they multiply the exponent when they're supposed to add. Who sees this difference? When do we add and when do we multiply? Do you guys see the difference? Some of you. Okay, you know what? I'm going to have you write this down first, and then as you write it, think about it. Look at the difference between the rule number 1, which is what we learned last time, versus now our new rule, if it's power to a power. Okay, look at the difference. How do you know when to add and when to multiply? And like I said, this is where people mess up. Okay, people do it the other way. Okay, and get it wrong. Think about it. Okay. Bella, what do you see? What sort of difference do you see?
Well, in rule 1,
Yeah.
times a to the n power.
Right.
And in rule 2, it's to the n power.
To the n power. So in other words, are we talking about the same sort of? Do we have the same? Are these two expressions the same? No. Okay. Did you want to add something, Dana? Yeah, you're right. So yeah, one of them is power to a power. The other is a to the m times a to the n. They're different, right? Dana, did you want to add something? Right. Look at the exponent. Look at the base of the exponent n. What's the base of this exponent n? A to the n power, right? Whereas these, well, base of this m is just a. Base of this n is a. That's another. Did anybody want to add something to that? Okay. So how are we going to remember this so that we don't get confused when we're doing, like, if you're taking a test? Sometimes there's so many things that you have to remember, right? That you have to understand. How are you going to remember that a to the m to the n is multiplication and a times a to the m times a to the n is addition for the exponents? How are you going to remember? Anybody see? Yes, Chris? 2 sets of parentheses? Oh, okay. So the rule 1, you have 2 sets of parentheses. And the other one? Okay. Another, yeah.
For rule 1,
Yeah.
there's distance between the exponent
Yeah.
of m and n.
Okay, yeah. So m and n are sort of far away because they both have the same base like this.
In rule 2,
Yeah.
m and n are right
Yeah.
next to
The
each other.
exponents are right next to each other. Does that make sense? So when the m and n are right next to each other, guess what? We multiply. When there's sort of like m is with the base of a and then n has the base of a, they have the same base. And you see how the exponents are sort of far away? That's when you add them together. You can think about it that way. Also, what you could do is, this is what I do. Before I take the test, on a blank sheet of paper, I actually do a simple example like this. And so what I do is I write x to the second to the third, and then I write it out. When in doubt, you should write it out. So you write it out, and you kind of convince yourself, oh, this is how we multiply, because 2 times 3 is 6. You know what I mean? Does that make sense? So you would actually write out your. So I would like actually do a simple problem like this, right, on the side. You know what I mean? And to convince myself, oh yeah, x to the second to the third, this means x to the second, x to the second, x to the second. You add the exponents and you get x to the sixth. The shortcut is you multiply the exponent. Does that make sense? This is what you should do. This is what I do. If I'm not convinced of the rules, I just do an example, really simple one. Okay? Yes?
What if that like takes too long? Like you don't have enough time.
Well, this should only take a couple seconds. You don't have time to do think not do this?
Oh. Okay.
But I wouldn't do this one. How come I wouldn't use this example? X to the second to the x second. This is a bad example. Why wouldn't I not use this simple? Isn't this simpler? You don't have to write as much. Why is it a bad example? Kevin?
It's a bad example because 2 plus 2 is 4 and 2 times 2 is 4.
Yeah, 2 plus 2 is 4, 2 times 2 is 4. So how do you know when to add or when? You know what I mean? But this would be a better example. Does that make sense? So just do this, Jason. It would not take you that long, right? To write x to the second to the third. Just write it out. And once you write it out, you know it becomes x to the sixth, right, guys? Then you know, right? Do you get that?
Yeah.
Okay, so that's what I would do. And this is what I do actually. Before I use these shortcuts, I want to be sure that I'm using the right shortcut, right? So I do little simple examples like this before I actually do these. All right. So knowing this, let's do some examples, okay? So here's example 1, has and 2 and 3 actually. So first one, it says m to the third to the fourth power. Example 2, x to the second to the fifth. And the other one, negative b in parentheses to the fourth. And then the whole thing is raised to the fifth power. Go ahead. See what you get. Okay, I'll wait. And of course, you could work as a group. That's fine. What kind of work do you think I want to see when you do these? Yeah? Yeah, for example, example 1, what kind of work do you think I'm looking for? Yeah, I want to see how you multiply the exponents. So I want you to write out like m to the 3 times 4. You see what I mean? And then that's how you get m to the 12. I don't want you to just do it in your head. You know what I'm talking about? Okay, go ahead, finish the rest, okay? Who can tell me how to do number example 2? How about Livy? What do I do here for example 2?
We write x to 2 times 5.
Exactly. We multiply the exponents. These exponents are right next to each other. You could think about that. Yeah, so what do we get? The answer is then?
X to the 10th.
Very good. How many people got x to the 10th? Raise your hand. Good. Question, Jason?
No.
Oh, okay. Anybody have any question? Okay, let's look at example 3. I put a star on this one, okay, because there's a reason why I did that. Okay, how about, who could help me? How about, Michael, what do you think I should do?
But for like the answer or how to do
Yeah, next step. What am I going to write next?
parentheses negative b to 4 times 5.
Exactly. Parentheses, negative b to the 4 times 5. Oops, I forgot to write that. I just wrote 20. Is that okay? Sorry. I should have shown that work. Then, after this, okay, I'm done, right?
No.
Oh, Christina, what'd you get?
Positive b.
Yeah, exactly. So you should always simplify this. You should write, how many people wrote down positive b to the 20th here?
I did.
Very good. If you stop right here, guys, you're not quite simplified. You haven't simplified this whole thing yet. Why do you think we get positive b to the 20th? Raise your hand if you could think you can explain. 1, 2, 3. Okay. How about Camilla? Exactly. Look at the base of the exponent 20. What is the base of that exponent 20, guys? Negative b. If you multiply negative thing even number of times, what happens to it? It becomes positive. So do you think that do you see how negative b in parentheses to the 20th power? Right? You should, whenever you simplify, you want to get rid of the parentheses as much as you can. And of course, we could get rid of this, can we?
Yes.
So we get negative b to the 20th. Are we okay there? Easy enough? Yes. Oh, okay. If you wanted to, yes, you could have actually seen that. Oh, negative b to the 4th inside the parentheses. That's just simply what? B to the 4th. And if you did it that way, that's totally fine. So I mean, actually, let me write that. Okay, that's fine. So if you did it this way, where another method of doing it is if you did it this way. Let me do it in a different color. So if you thought following the order of operation, right? Inside the parentheses, you could always simplify this, can't you? So maybe this is better. So you say, oh, negative b to the 4th, you multiply negative b 4 times. What do you get, guys? B to the 4th. And it's still raised to the 5th power, correct? So you just get b to the, you get the same answer. Is that okay?
Yeah.
So you could think of it either way, still get the same answer. Very good. Any other question? So there are two ways of thinking about this. You could either just multiply the exponents as we learned it, or use the order, follow the order of operation and simplify before you get going. Okay? All right, may I show you example 3b? I want to show you example 3b. Go ahead, hold on. Before I show you example 3b, let me ask you this. What if what if the answer came out to be like negative b in parentheses to the 19th power? What would you write? Is this simplified? Negative b to... Not quite, because we could actually get rid of that parentheses. So whenever you simplify, you don't want to see any parentheses, as much as, if you can. So there is a way to get rid of that parentheses. Anybody see what I could write? Instead of writing negative b in parentheses to the 19th power? Sorry. Yeah. If the answer came out to be negative b in parentheses to the 19th power, how would you simplify this? Jason?
Negative b to the 19th without parentheses.
Okay. Dana, what do you think? Put negative in parentheses? Not quite. Carly? No, that would be wrong. You cannot move the negative to the exponent. That means something totally wrong. Carolyn?
You can put the b and to the 19th power parentheses and then the negative.
So it's sort of like Jason, right? Yeah. What do you think, Roy?
The answer?
Yeah.
Well, negative b to the 19th.
Yeah, it'll just be negative. Jason is correct. This becomes negative b to the 19. Anybody see why this becomes just simply negative b to the 19? Look at what we have here. Negative b in parentheses to the 19th power, Eric, is same as negative b to the 19th power. Why? Eric?
Because you're multiplying by an odd number.
Exactly. You're multiplying a negative number or negative expression. You could think of it this way. Odd number of times. Of course, it's going to be negative. Do you see that? Whereas the other case, when if the negative base is to the even number of power, of course the whole thing becomes positive. Is that okay, guys?
Mm-hmm.
All right. So now we're ready for example 3b. Here's example 3b, and do you see why I called it example 3b? Because they're very similar. Example 3 and example 3b, right? Go ahead, everybody try. See what you get for example 3b. We know the answer for example 3, don't we? We got b to the 20th, right? What about then example 3b? Even though they look very similar, I don't think you're going to get the same answer. Go ahead, everybody try. Let's go over this then. All right, first of all, how many people think that this whole thing will come out to be positive? Raise your hand. Okay, how many people think it will come out to be negative? Okay, you guys are correct. It does come out to be negative because look at the base. What is the base of this 5? Negative b to the 4th, correct? And negative b to the 4th is negative, isn't it? So, yeah, because you can think of it as negative 1 times b to the 4th to the 5th. What do you get if you multiply negative 1 5 times? Negative 1, right? What's b to the 4th to the 5th? 20. So how many people got negative b to the 20th? Raise your hand.
Yeah.
Do you see that? Any question? If you got that, then try this. What do you get for this one?
2 stars?
Yeah. They both have 2 stars. Example 3c. They all look similar. But what do you think you get for this one? Go ahead, everybody try. Raise your hand if you guys got positive b to the 24. How many got positive b to the 24? Just 2 of you. How many got negative b to the 24? You guys are all wrong. Okay. All right. So Brandon is one of the person that got positive. Brandon, how did you get positive answer?
Okay. Wait, you want to know how I did it?
Yeah.
Okay, so I did negative b to the 4 times 6, and then negative b parentheses to the 24th, and then that's a b to the 24th.
What happens to the negative?
Okay, it goes away because
What?
it's an even.
Yeah. Look. How many times am I what's the base of this 6, class?
Negative b to the
Negative b to the 4th, right? That expression is negative, right? To start with.
And then
Let me ask you this first. Hold on. Look at the 4 here. What is the base of that 4? Is it b or negative b?
negative
No. Just the 4.
b.
It's b only. It doesn't have any parentheses. So this whole expression is negative. Correct? So if you multiply negative things even number of times, what happens?
It becomes
Positive.
It becomes positive. You could also even think about that as negative, invisible negative 1. Isn't this really negative 1 times negative 1 times negative 1 6 times? And then b to the 4th, b to the 4th, b to the 4th 6 times. So that's why this becomes positive b to the 24.
Then how come, for example, the 3b, it was 20's even, so why was
Okay, let's go back to example 3b. Okay, hold on. Okay, Carolyn, you had a question. Here's example 3b. I copied it again, right? What is the base of this exponent? 5.
negative b to the 4th?
But how many times are you multiplying it? Which is odd or even? And when you multiply odd number, negative number, odd number of times, does it become positive or negative?
Negative.
That's why. That's the difference right here. So look at this one. Here I am multiplying this odd base even number of times. That's why it became positive. Does that make sense?
So it doesn't matter whenever you multiply the 4 and 5, it matters like the outside one?
Right, so just think about how many times you're multiplying this negative base. If you're multiplying it odd number of times, it's still going to remain negative. If you're going to multiply this negative base, right, even number of times, it's going to be positive. You could even think about it as, you could think about it as separately. This is negative 1 times b to the 4th, right? How many times will you be multiplying negative 1 then, if you're going to multiply this whole base 6 times? 6 times. What's negative 1 to the 6th power? Or if you multiply negative 1 6 times, it's going to be positive 1. Do you see the difference? Do you guys see the difference, guys? So do you see why I did these examples 3, A, B, C?
Yeah.
Okay, do you see the difference? Do you see that? Yeah, sometimes you gotta be careful, right? What happens if you forget the negative? Yeah, you have to be careful, okay? All right, let's look at next example. So along that line, look at example 4. I have now, instead of just y, now I have 2y. It's got some coefficient other than 1. 2y to the 4th power. What does this mean? This time it's sort of different. I don't have power to a power, right? I just have 2y to the 4th power. What does it mean here? What's the base of this 4, Sammy? What is the base of this exponent 4? 2y. So how many times are we multiplying 2y?
4 times.
4 times. So let's write it out. 2y times 2y. By the way, I wrote down invisible 1 for each exponent. Is that okay? What's exponent for 2? Yeah, it's 2 to the really what? 2 to the 1 power. What's exponent for y? 1, right? Y to the 1st power. That's why when you multiply these, you get 2 to the what power? How many 2's do you have? 4. So that's what it's same as 1 plus 1 plus 1 plus 1, isn't it? That's 4, right? Y to the 1 plus. So again, you get y to the 4th again, don't you?
Yeah.
The answer is 16 y to the 4th.
Wait, why it's a 4?
Wait,
What?
I got that. No,
Wait,
shouldn't it just be 16y?
no.
Yeah, because 4y is like the y.
I am multiplying y 4 times.
No, I know, wait. Aren't you just multiplying 2y times 2y
No,
is
because you're
4y times 2y is 8y times 2y is 16y?
Okay. All right, Jason. I can rewrite this as. Give me a sec here. I'll convince you. Jason,
Yeah.
like we said just now, when in doubt, you should write it out. If I write it out, as you can see, you get y to the 4th. You're thinking of addition. If I were to add 2y plus 2y plus 2y plus 2y, then you get what? You get 8y to the 8y, right? But that's we're not adding them. Yeah, in that case, the y stays the same. But we're multiplying all these factors, right? 2 times 2 times 2 times 2, and then y times 1.
Oh, I see what you
Okay, does that make sense? Do you see why this is, even though this is easy, why people make mistake? Oh, okay. Sorry. Do you understand, guys? Do you see why it's really easy to make mistakes? Okay. Yeah, even though it's really easy in terms of actually getting the answer, if you use the wrong method, are you going to get the right answer? No, of course not. Okay, if you got that, try this one then. Okay. What if I have x to the 2nd, y to the 4th, to the 3rd power? What do you think we get? You could even write it out if you want. That's what I will do here at this point. Go ahead. On example 4, many times people give me the answer as 2 to the 4th power. Would this be right? Dana, why would this be wrong on example 4 if you give me the answer as 2 to the 4th? Yeah, you could actually think about it. Yeah, you have to kind of share this 4 with all, right? If I write, do you see why people would write 2 to the 4th by mistake?
Yes.
Michael, why would they do that?
Because they would think that they're kind of like 1.
Yeah, what is the base of this exponent 4? Is it just y or is it 2y?
Why?
the exponent of this 4 right here, even though there's a parentheses?
2y.
Yeah, the base is 2y. Therefore, you'll be multiplying 2's also, okay? 4 times. Don't do this. Does that make sense, guys? Do you see why? Did you just look at 2y to the 4th and just write 2y to the 4th? That'd be wrong. Because there's a parenthesis around 2y, right? You'll be multiplying 2 4 times as well. Does that make sense? Because if you write it 2y to the 4th, what's the base of this 4 then? Just a y, right? Do you see how it'd be wrong? Okay, so let's look at example 4b. What does this mean? X to the second, y to the 4th, to the 3rd power. What is the base of this exponent 3? Claire?
Base of the exponent 3,
Mm-hmm.
x to the second, y to the fourth.
That's correct. It's the whole x to the second, y to the 4th. How many of these are we multiplying? Class? 3 times. So isn't it really x to the second, x, y to the 4th, x to the second times y to the 4th, x to the second, y times the 4th? Jason, now, look, we're all multiplying. We're not adding or anything, right? What do you think? How many x's do you have, Jason, here?
6.
6 of them. How many y's do you have?
12.
12 of these, okay? How many people got x to 6, y to 12 as your answer? Raise your hand. Okay, does this make sense? Questions? Do you get this? Okay, so anybody see any sort of... Okay, so knowing this, let's see. So here comes our 3rd rule. If I have, instead of just one factor inside, right, the parentheses, if I have ab to the n power, what does this mean? What is the base of this m, class? Camilla? AB. And how many ABs are we multiplying, Camilla? M times. So anybody know the shortcut? Looking at the previous examples, this would always get you this result. What do you think? Aaron?
Is that an M?
Yes.
A, M, B, M?
Yeah, a to the n power and b to the n power. Does that make sense? This is our 3rd rule. Okay, if you have more than one factor inside, you gotta multiply, right? The whole thing m times. In other words, a to the n power really means what? am times am times. How many am's do we have? M of these. So how many a's do you get? M. How many b's do you get? M of them, right? All multiplying. Do you see why it becomes a to the m times b to the n power? Right? If I have a to the n power. Are we okay with this? Do you only have, can I have more than 2 factors inside? Could I have 3 factors? What if I had abc to the n power? What are you going to get? A to the m, b to the m, and c to the m. Okay, so I could, if I have a, b, c to the m power, you don't just have to have 2, right? You get what? A to the m, b to the m, and c to the m. As you can see, I can have as many factors I want. Does that make sense? Any question? Notice what's happening between a, b, and c. What operations are there between them? Multiplication. Do you think you'll get the same answer if I have like addition or subtraction in them? No, it will not work. Okay? That's going to be different. We're going to be talking about, we'll talk about that later. Look at our topic today. What are we multiplying? These are powers of monomials. What do you have to have inside here? This is a monomial, right? Okay? If you have addition sign inside, then do you have a monomial? No. You have what? Binomial. Or you could have trinomial if you have 2 addition signs, right? Do you guys see this? This only works for what kind of polynomial? Monomial. Does that make sense? Everything has to be multiplication inside. Alright, keep that in mind. Okay, let's look at some examples then. Alright, take a look at example 5. Look at my monomial. Okay. How many, can I call them factors or could I call them terms? Could I call them terms? -4 m and n? Are they terms or factors? Terms are separated by addition sign. Are these terms? No, these are called factors. How many factors do you see inside the parentheses? 3 of them. And all those 3 factors will be multiplied how many times? Twice, right? Because the whole thing is raised to the 2nd power, correct? Because the base of this exponent 2 is -4 m and n. Okay, what do you think the answer is? Okay, I'll give you time. Go ahead. Everybody think about this. We have 3 factors inside. Okay, this monomial has 3 factors. The whole thing is raised to the 2nd power. What do you think we get? Go ahead. Let's do this one. Dakota, what do you think I'll get using the 3rd rule that you just learned? What do you think we get here? Exactly. -4 to the 2nd, m to the 2nd, and n to the 2nd, right? Then Paige, do you think I need a parentheses around -4 or no parentheses?
Yes.
Yes, I do. You're right. Why do I need parentheses around -4? Like this, right? Why would I need that?
Because it has a negative sign.
Yeah, not only that, how many are we multiplying -4 twice or just 4 twice? -4 twice. Does that make sense? Because -4 is inside the whole parentheses. So the answer, how many people got the answer as positive 16 m squared n squared? Raise your hand. Very good. If you didn't get this, do you see what you did wrong? Any questions? Okay, try this one yourself then. How many factors do you see inside the parentheses? Two. What's the first factor? Negative m. The other is n. Is that right? Go ahead, everybody try. Again, what are the two factors that you see inside? Negative m and n. So how many people did negative m to the third and n to the third like this? Okay, let me ask you this now. Christina, if I multiply negative m to the third, what do you think I get? What would negative m in parentheses to the third give you if you want to multiply that out? Yeah, which is? Would it be negative or positive?
Negative.
Right, and how many m's would you have? So what would you write? Yeah, negative what? Negative m to the third. Isn't this what you get here? Right? What about n to the third? If you multiply n 3 times, don't you just get n to the third?
Yeah.
How many people got the whole answer as negative m to the third, n to the third? That's your answer. Do you see why it's negative m to the third, n to the third? Okay. How many people thought of it this way? How many people, a lot of you said there were two factors. How many people thought of it this way? -1 times m times n. How many people thought of it this way? Did anybody? To the third power. Could you think of it this way? Then if you did this, what do you get? -1 to the third, m to the third, n to the third, and do we get the same answer? Right? Because isn't that really invisible 1? You could think of that invisible 1 as its factor. So you could think of this as a factor of this whole thing. Right? Any question? Okay, let's do one more then. Okay. Here's example 7. Go ahead. -4, a to the third, b to the second, the whole thing to the fourth power. How many factors do you see in here? 3 factors. Okay, go ahead, everybody try. Okay, how many people did this first? -4 in parentheses to the third, fourth, a to the third to the fourth, and b to the second to the fourth. How many people did this? Michael, what do I get? Next.
We got
Positive or negative for the first number?
positive.
Positive. Did you all get positive? Because you'll be multiplying that -4, and then what is 4 to the fourth power? Anybody? 200? That's right. And what about 8 to the 12 and b to the 8? Do you multiply? Could I write it this way? -4 to the fourth like this without parentheses. What would this be? -4 to the fourth without parentheses on the bottom. It'll be negative. Would that be right? No. Okay. Any question? Because 4 times 4 is 16. 4 times 4 is 16. What's 16 times 16? Multiply it out. It's 256. 4 to the fourth power, it means 4 times 4 times 4 times 4. Okay. It's not 4 times 4, is it? Any questions? That'll be good. Okay. Any questions? All right, good. Go ahead and do example 8. It says evaluate if x equals to -2, and all these 3 expressions, they look very similar, right? 3 to the x to the third, 3x, parentheses to the third, 3 to the third, x to the third. Okay. Tell me what you get. Do you think you're going to get the same answer for all these? Probably not, right? Anyway, when you evaluate, what should you always use? Use the parentheses, right, guys? Do you think that's going to be helpful? Please do use parentheses when you substitute it in or evaluate, okay? When you plug this thing in, you need the parentheses. Go ahead, everybody try. I'll wait. Go. How many people for A? First of all, let's do A together. First of all, did you guys put parentheses like this first? And then plug in something? What goes inside here? How about Angie? Tell me what to write next. So 3 parentheses -2, right? Angie, what do you get when you multiply -2? By the way, can I multiply -2 times -2, Angie? Is that okay? Can I multiply 3 times negative 2 first? Why not? You're right. I can't do this. I cannot get, I shouldn't put negative 6 to the third power at this point. So we know why not.
Because you have to follow order of operations.
Thank you. Order of operation always, right? You have to always use order of operation, okay? So when you do, what do we get here? What should we do next here? How about Elisa?
You get 3 times negative 8.
Yeah, you get 3 times
Negative 8.
negative 3.
Negative 8.
Negative 8 is correct. And what's the answer, class? Negative 24. How many? Raise your hand if you got negative 24. Very good. Any question? Let's look at the second one then, okay? Rania, can you help me how to do the second one? Did you use this parentheses like this for?
Yeah.
Okay, then did you plug in like this? 3 times negative 2. Okay, now what do I do next?
Then I get 3 to the power 3.
Oh, you did 3 to the power 3 and negative 2 to the power 3 in parentheses? You could do it that way, but let's follow the order of operation.
So multiply negative 2 and 3.
Yeah, now this time you can multiply negative 2 and 3 because they're inside the parentheses. Do you see the difference? So you get negative 6 to the third power, don't you? Because it's positive times negative, correct? So then, with the answer should come out to be negative. Did anybody get, what did you get? 200? Yeah, and then it should be negative, right? Would you agree? Any question? All right. Raise your hand if you got negative 216 on that one. Okay. Did anybody distribute that exponent? Again, I'm using that word, but I shouldn't really. 3 to the third, negative 2 to the third. Did you? Okay, you did that. Did you get the same answer? Yeah, because you get the same answer because, okay, so Eric, for 3, you get 3 to the third and negative 2 to the third, don't you? And don't you get 27 times negative 8? Still the same answer. But do you see how these are similar? These two?
They get the same answer.
Yeah, because, yeah, this will be the same. Because in other words, you could have used that rule. You know that third rule we learned? So you could have used 3 to the third, negative 2 to the third power. Or, isn't this a lot easier though, following the order of operation? Just do 3 times negative 2 and then get 6. Do you guys see how we get the similar answer for the last two? Where the first one is really different, isn't it? Hello? Okay, any question on these? Are we good? Alright. So let's remember the first rule. Hold on, guys. Before we go, here. What is our first rule that we learned? You add the exponents, right? Can somebody tell me how when we add? Raise your hand. Yes. A to the m power a to the n. Then that's when you add, right? When do we multiply the exponents? Cole? A to the?
When it's like the second and parentheses to the third power.
Right. A to the, like m to the nth power. When do we distribute those exponents? When, if you have more than one factor inside. So if I have ab to the m, then you get a to the m and b to the m. Do you guys see the difference? Any questions? Okay.